today we have Foroogh with us, and she will tell us something about a very recent paper of her PhD thesis, which is on how children perceive the world around them, and especially the question why we cannot wait for Christmas to come.
That's true. So yes, the ground rule of this study is actually looking into the cognitive developmental aspects of the brain. So imagine when we were younger, how we were perceiving the world. So for example, waiting for a lunch to be cooked by mom, or like playing the moment that we were playing with our peers or our friends. But before answering this question, first we have to look into the brains of the adults. So how's it working there?
Yeah.
So we, through the last 2 decades, there is a theory called event segmentation theory that it's actually trying to say how we perceive the world around us. So we are always continuously exposed to the stream of the information and the experiences and events that is around us, but this is not how our brains actually perceive it. So our brains always try to segment and divide the events into the meaningful events and try to perceive it and do the perceptions, and this is a theory that is actually looking into such a fact.
So our continuous stream of information is not seen as a continuous stream, but is encapsulated in time bins, so to say. One of these are more important than others, of course, and through these binning you will try to get some sense into how to best behave in your environment. Is that true?
Exactly, that's true, yeah. So there are also a lot of studies before that they did with the fMRIs, for example, but here we also did a very fundamental study with the EEG, in which we could show that what are the brain regions and what are the oscillatory frequency bands that they're actually important for such perception or such theory. Yeah.
All right. So what did you find out then exactly in terms of the oscillations and how the different brain regions communicate?
So what we found that as we are younger, of course, it's our access to the knowledge system is a little bit limited, maybe compared to the time that we are adults, so like nowadays wise. And yes, so we actually could see that for our younger group in the behavioral level, they do have these different lenses of how they are looking into these events and how they are perceiving that. They were maybe more into these temporal jumps that it was actually happening in the movie. But compared to the adults, adults were like more interested, or let's say it was more important for them to get these interaction behaviors that it was happening in the movie. Any kind of behavior, like for example, interaction with another humans or an object, or any kind of interaction that was happening in the environment. But in a neurophysiological level, this assumption that maybe our younger groups have this limited access to the knowledge system was also shown by the the alpha band oscillations.
So adults do attend more to some specific sort of events to structure their environment, whereas children do it otherwise. But nevertheless, they engage similar or different mechanisms in how they do it and how they bin their environment. So what's the point? So
they actually use the same mechanism. So both of the groups, they're actually segmenting the events, and as the number of these changes in the movie was actually increased, the probability that both of the groups were actually segmenting and doing a segmentation behavior was also increased. But for the younger group was less likely. So it was like, quantity-wise it was less compared to the adults, but they use the same mechanism. Yeah.
So they see the stream of information more as a flow with less segments, so to say, which may be one reason why they get bored, cannot wait for the next event to come, so to say. Whereas for adults, time is a bit more flying because they perceive their environment into more and interchangeable bins as compared to children.
Exactly. So for the children, it was all these events were longer and perceiving as longer. So because also they are not that much experienced, so these previous knowledge or experiences, which is also represented by even schemata in this model, was actually less compared to the adults. So that's why maybe for them it was taking more time to see the next events. This is how they perceive it. Yes. We could also see this in the neurophysiological level by the alpha band activity, as I mentioned that alpha band activity that is representing this access to the knowledge system, or the fact that it's helping to ignore the irrelevant information, which is in medial frontal cortex and occipito-temporal cortex. There was actually a very vivid pattern of connectivity between them in the adults, but not the adolescents. We could also show this by seeing a correlation of this connectivity pattern for the adults with the behavioral pattern of them and results, and not for the adolescents.
So adults have a bit more of a top-down control and are more actively engaged in getting into the knowledge system what's important, what maybe not that much important, whereas children and adolescents are a bit more lenient in that process, and therefore, let's say, divide their environment into fewer bins.
Exactly. That was really nice said, yes.
Yeah, so there's a different strategy behind. Or is it because they have stronger experiences about what is to come next in adults as compared to adolescents?
Yes. So of course, as an adult, we have more. So we have this skill to predict more, and so we are expecting some things to happen because we are more knowledgeable. We use this source of knowledge that we have, but this is not the case for the adolescents. Yes.
Okay. And what about other forms of brain activity? I mean, you already talked about alpha band activity, but what about, for example, theta or beta band activity? What's around there?
So for the theta band activity that is actually representing this prediction error or this expectation that we have about what is going to come next as new events, was actually, let's say, more comprehensive for the adults compared to the adolescents. So our adults were more able to do the prediction, and they have this control over this information that they were actually getting into. And also the same for the beta band. There was a better communication between the brain regions for the adults compared to the adolescents. That was also something that we could, again, says that this is maybe because of the process of maturation that they're going through. Yeah.
Okay, but what is more decisive, alpha, theta, or beta?
Alpha.
Who wins? Okay, alpha wins.
Because we could see that by the really end that we have this correlation of alpha band activity with our behavioral results. So we can somehow say that maybe our adolescents, they are using different source of information. For example, maybe more low-level kind of cognitive load of information compared to the adults where they are using more complex kind of information. Yes.
So it's not that much that younger children or adolescents cannot predict what's going on, which is theta band activity, which makes a difference. Neither it is the ability to, let's say, keep the information hold in working memory, which is beta band activity. It's more about how strict or more lenient I am in getting information and transferring this into my knowledge system or my event schemata.
Yes.
To decide, okay, what is the natural change that it's relevant for me, whereas other things that become more and more relevant for me as I grew up.
Exactly.
So what's the implication about that?
So, of course, this is a very fundamental approach of us. As I also mentioned, we had other works that we were trying to reach to a very more or bigger goals, which we are trying to replicate the same studies for the other groups of children or adolescents that they have the ADHD disorders. So, like, we are trying to see the traces of these cognitive impairments of attention and perception when it comes to these kind of disorders. So far, we also had a publication, we had another work that we actually look into the differences that it might be between the ADHD children and with their neurotypical developmental peers, which definitely they can check it out. But yes, so this is our main goal. We are trying to reach there and we try to apply it in the clinical aspects. Yeah.
Well, that's really fascinating. And I assume that especially when you are growing older and when you're developing, there are several things that can happen which can be shown in ADHD, but I would think that there are also other neurodevelopmental disorders that may be relevant for it. For example, autism spectrum disorder may be relevant to look at, but also different treatments and how far different treatments that are already around, for example, ADHD, may impact how these children and adolescents perceive their environment, because this could really be key to how they behave then, because this is a fundamental problem of these people.
Exactly. I think as far as we are covering the attention and perception, we can look into that, yes.
Fascinating. That's great. Hey, Foroogh, thank you very much for being with us, and thank you very much for watching us. Bye-bye.